Okay, so there were two more examples, AP questions, 2011 and 2015. So, particle is moving along the x-axis, position is not given, but the velocity is given by this, and the acceleration is given by this. So immediately we would type that into y1, we would type this into y2, and it says, is the speed of the particle increasing or decreasing? So if we're looking at speed, we want to know the sign. We're looking at the signs of the velocity at 5.5 and the acceleration at 5.5. So we can type those in the calculator. So if we have y1 typed in the calculator in the home screen, we can write y1 of 5.5, and it will give us the answer. So this is going to be negative 4.53, and we can do the same thing. y2 of 5.5, that's going to be negative 1.359. Okay, so based on that, hopefully you all know what to say. We would say the speed is, tossing the pen in the air, speed is increasing because v of 5.5 and a of 5.5 have the same sign. And not that they're both negative, it's that they have the same sign. If you say it's because they're both negative, that seems to imply that they both have to be negative. They don't have to be negative, they just have to be the same sign. So they could both be positive or they both could be negative. So we don't want to get caught up in that. Okay. Find the average velocity. So I keep talking about this. I just mentioned that on the previous page there. So the average velocity is going to be 1 over b minus a. Okay. And the average velocity, if we integrate the velocity, we get the position. So that would give us the total change in position. So we can just type that in the calculator. We can integrate y1 from 0 to 6. And if you don't know how to type that, and if we think about the units, this is time and this is position when you integrate velocity. And if you need to know how to do that in the calculator, you could come to office hours and ask me. But that's the average position. So based on what we have typed in, we would type the integral, and then we would type in y1 of x, comma 0, comma 6. I think this puts a parenthesis here also. So don't forget to close that parenthesis, and don't forget to close that parenthesis. And then that would, then you would have to divide that by 6, because we have the 1/6 there. So that's how you would type it in our calculators. Okay, so pretty nice stuff so far, actually. Now, find the total distance. So I can't remember if this has come up or not, total distance. But total distance is the absolute value of velocity. So from 0 to 6, you're just going to write the absolute value of velocity there. And just writing integrals usually gets you a point. So this is probably worth a point. This is probably worth a point. So you want to get in the habit of writing those integrals down on the free response questions. So practice this on your calculator, all of these, and make sure you get these same numbers, these same decimals on your calculator. Total distance. This is a great question. We hope there's something like that on there. It's very reasonable. Okay. Particle changes direction. Okay. Well, the particle changes direction when it's changes direction. That happens when the velocity changes signs. if you think about it, think about the pen being thrown in the air. When the pen is thrown in the air, it's going up because it has a positive velocity, and then when it starts to come back down, it has a negative velocity. So when the velocity changes signs, the pen changes directions. Okay? So we need to know when v of t equals 0. All right? So we can do that on the calculator. We can look at y1 and see when y1 equals 0. And if we do that, we see that it is at 5.196. And we're going to store that into A. All right. Actually, it's already stored in XC if you found it. If you found the 0 on the graph, it automatically stores it in XC, so you don't have to restore it in A if you don't want to. But okay, find the position of the particle at that time. The position of the particle when it changes direction. So if we integrate the velocity from 0 to A, or XC here, that's probably why I used A because it looks better there. That's going to equal the position at A minus the position at 0, which we have right up there is 2. This equals 2. So x of A is going to equal 2 plus this integral, which we would need to type in our calculator. And that should turn out to be 14.135. Now, it's important that you duplicate those numbers on your calculator. If you can't do that, then you need to come to office hours, and I need to redo that question, and we need to talk our way through that. Okay. So, let's look at this one. And twice differentiable. So usually that's also telling us it is, not that we may or may not need it, but it's going to be continuous also. If it's differentiable, it's continuous. Remember, the converse of that is not necessarily true. All right. Find all of the coordinates at which f has a relative maximum. Give you a reason. So here's the derivative. We have a relative maximum when the derivative, when f prime of x changes from positive to negative. That's when we have relative minimums and relative maximums. Because when the derivative of f changes from positive to negative, f changes from increasing to decreasing. And that will give us a maximum. So changes from positive to negative right here. So when x equals -2, because f prime of x changes from positive to negative. So there's our answer for that one. All right, so let's look at B. Okay, on what open intervals is the graph both concave down and decreasing? Okay, so let's think about that. I don't think I can squeeze that in there very well, so I'm going to move it down here. So B. So it says concave down. So concave down is going to be because f double prime of x is less than 0. Okay? Now, when is that going to be less than 0? That's going to be less than 0 when f prime of x is decreasing, right? So because that's the derivative of that. So when that's negative, when the second derivative of f is negative, the first derivative of f is decreasing. So that's going to occur from, what are we going from here? -3. So -3 to -1 and from 1 to 3. Okay, then we also wanted f to be decreasing. So f decreasing is because f prime of x is less than 0. Okay, so f prime of x is less than 0. Well, that we can just see right here. Here's f prime. It's less than 0 when it's below the axis there. So that's going to be -2 to 1 and 1 to 4. Don't include the 1 because that's 0 and that's not working. So where do we have both of those things? So -3 to -1 is here, and 1 to 3 is here. So that's f double prime less than 0. And below here, I'm going to put f prime less than 0. So that's -2 to 1 and 1 to 4. So the overlap is there and there. So that's going to be -2 to -1 and 1 to 3. All right. Now, part C. Find the x-coordinates of all points of inflection on the graph of f. Give a reason for your answer. Okay, so x equals. Points of inflection occur when the second derivative changes signs. So the second derivative is right here. And it changed signs here, here, and here. So, because I'm looking up there, it was negative. The second derivative was negative. Then it became positive at -1. So that's going to be -1, and then +1, and then +3. Because f double prime of x changed signs, and f of x is defined at those points, at those values. Okay, finally, this is just a little side note. In 2016, 11 students out of 310,000 got a perfect score. 11 out of 310,000. Okay, so let's look at the last part of this here. Given that f of 1 equals 3, find an expression for f of x that involves an integral, and then find f of 4 and f of -2. Okay, so we want to use that, and then we want to find these. So if we want to find values of f, we want to integrate f prime. Okay, and we want to use a different variable there. Different variable here. So we're finding for x here. So this is going to be f of x minus f of 1. And so if we add that to the other side, then our function will be f of x equals, f of 1 was 3, so this would be -3, so we add that over there. That's going to be 3 plus 1 to x f prime of t dt. So that's our function for x. Now we need to use that to find 4 and negative 2. So if we put a 4 in there, so f4 is equal to 3 plus the integral from 1 to 4 of f prime of t dt. Well, 1 to 4 is this thing. They told us from 1 to 4, it says the area of the regions bounded are 9 and 12. So it's telling us this is 9 and this is 12. Okay? So if we're doing the integral from 1 to 4, that's going to be negative 12. So this is going to be 3 minus 12. So that's going to be negative 9. And if we want to do, what's the other one? Negative 2. So that's going to be 3 plus, and this is going to be 1 to negative 2. And we're going to have to switch. We're going to have to do a flip because these are backwards. So that's going to be 3. We flip those over. That's going to be minus. And then from negative 2 to 1 is right here. That's 9. That was a negative 9. So that's going to be 3 plus 9. That's going to be 12. Okay? Now we're done with chapter 4, pretty much. Have a good day.